Here is an example of an actual Visual Basic program that's in use. It's an option pricing code within an Excel spreadsheet, and it performs Black-Scholes estimation of European call and put options, and also does a binomial tree evaluation of the price. And you can see here the prices of the calls are very similar by those two measures. If I reduce the number of steps, then the accuracy here would go down. So they become a bit more different. It takes an appreciable amount of time with 1,000. The code underlying that is this. Code for the Black-Scholes is relatively simple, but the code for the binomial is a lot more complicated, and it also is made difficult to analyze because there's no types here. They're typeless declarations. But we can analyze that, so that can be parsed using the Antler Visual Basic parser. We can then put it through our tool, through the UML RSDS Agile UML tool. One thing we need is the mathlib library and the Excel library, which provide underlying functions, which provide a library of OCL functions for mathematical functions, and in particular all of the application functions that you can call in Excel. So that's quite a large package of functions, and then we can parse the actual program, analyze the actual program, convert that to OCL and UML. It takes about 3 seconds. What does it look like in OCL UML? Well, it's like this, and the fact there's no types declared in the original code means that the types in OCL are simply OCL any. Now that could be a problem because a lot of these functions depend on the fact that we are manipulating real numbers. So to deal with that, we have to do some type checking first of all to try and deduce what the types are. We'll get some error messages on a first iteration. After a second iteration of type checking, all of the types have been deduced to be doubles, and then I can do the code generation in Python. So that's also fairly quick. So there's our generated app. Our generated app looks like this. The code of that Visual Basic has been translated into equivalent code of Python, where the Excel library is used for functions like the normal distribution, the cumulative normal distribution function, and functions like maximum as well. So that's our code in Python. Let's take the code that was actually generated just now. We still need that. Bit of test code. So the program that was just generated now is this. I need also to import Excel. So it's an implementation in Python of the Excel functions. And then a bit of test code. And this test code calls the BS call and put and the binary tree call with the same parameters in the spreadsheet. And The result, hopefully, is the same. So these are calls with the same underlying price, strike price, volatility, interest rate, time to maturity of 3/4 of a year, and 1,000 steps, and we can see that the results are identical effectively.